Shut your mouth. We are going to look at the polar coordinate and talk about how doth thou change it to a rectangular form. And now you're thinking, what the heck is rectangular form? How do I know what you're thinking, you say? I'm going to make something up. 30 degrees. This is polar form of a coordinate. It's R, then it's, what's that thing called? Theta. That's right, theta. So what we do is we go 30 degrees up, and then we go out until we hit a distance of 3. So the distance right here is 3. It goes 3 out. 3 circles. 1, 2, and then 3. Don't make fun of my circles. Now, the question you asked before, what is rectangular form? Rectangular form is normal form. It is Cartesian plane form. It is X and Y.
I was like, Cartesian, what? Would that just be like red?
Polar is R theta. I put him up there next to the polar. There it is. And then rectangular is the X and the Y. Could you make a guess? This would be 1, this would be 2, this would be 3. What would this be? The X and the Y. This is a good question, right? Okay, so you guys learned last week, we learned about vectors. You guys remember vectors? And with vectors, we learned about vectors that are 1 unit long. And those are familiar to you because you guys are very familiar with the unit circle. If I say this point right here, you guys know the rectangular coordinates for this point right here. What are the rectangular coordinates for this point right here? Negative 1/2. And then rad 3 over 2. Okay, my thing is not writing right now, but okay, there we go. Rad 3 over 2. We can see, yes. Okay, and then we learn this. A vector of length 1. Just one length is negative rad 3 or rad negative 1. Dang it. I cannot say the words. Okay, this is a unit vector, and I say I want vector to not be 1 unit. I want vector to be 5 units. What do? You multiply vector by scalar. A scalar of 5, that would be sufficient. So then I would go negative 5 over 2, and then I have 5 rad 3 over 2, and this is vector pointing in the same direction but of length 5.
I see.
Do you guys know, if I graph this vector right here, what are the coordinates at the end of this vector? It's the same thing, right? The coordinates are the same as the vector. So, I have a question for you. What the heck is this in coordinate or rectangular form? We know if this was vector, it would be length 3, right? What would length be if we were at 1 vector? Do you guys know? It would be rad 3 over 2 and 1/2. You guys know this, right? And so how do we get it way out here? We just have to multiply by 3. We just go 3 times 1/2. We get 3 over 2. And 3 times rad 3 over... Wait, that was wrong. Okay, 3 times rad 3 over 2, that'd be 3 rad 3 over 2. And then 3 times 1/2, that'd be 3 over 2. That's it. This is your rectangular coordinates for this polar point. Is this hard? No. You can actually write different way. You can say 3, and you can say cosine of 30 degrees, and 3 times sine of 30 degrees. This is not news to you. You know this. You know that rad 3 over 2 is cosine of 30 degrees. You know that 1/2 is sine of 30 degrees. See? Rad 3 over 2 and 1/2.
Is that what you do when you get
Yes. And if you guys still are lost, you can use a formula. X will be the r times cosine of the theta. And y would be r times the sine of the theta.